So they could be called zeros, or they could be called x-intercepts. So you could see them written any way on a quiz or a test. The number of solutions always matches the highest degree. So if you had an x to the 56th power, then it would have 56 solutions. So it always matches the highest degree. So looking at this equation right here, how many solutions does this equation have? 3. So I want you to put it into your calculator. And I want you to graph it. Okay, so equal 0 just means like where does it cross the x-axis, or that's what it means when you're talking about the solution. So essentially, where does it cross this line right here? And what point is that? -5. That's what mine is. Did I type it in right? Did y'all get -5?
I just did the 0 thing.
Yeah, try it on your calculator. You should get -5. How come I can only see one of the solutions? But I found that there are 3 of them.
I'm sure that they're imaginary.
I'm sure that they're imaginary, right? They probably are. So, and it's not going to be hard, but let's try solving for the other 2. This is pretty cool. So I can only see one of them, but it has 2 terms. So 1, 2, which means it's an x cubed. So let's solve for the other 2 solutions.
How are those imaginary? It clearly doesn't ever pass the x-axis.
Exactly. It actually passes them in a 3rd dimension.
Oh my god. What? Okay.
So,
We're taking it too far. Alright, who made this up?
all right. Guys, just stay with me for a second. I promise you're going to be fine.
How are we supposed to know how many you have in the first place?
X cubed. 3 solutions. You found one at -5. So let's do synthetic division on -5. What are the coefficients that go across? 1, 5, 4, 20. Good. So you should get 1, 0, 4, 0. Are we good at that? How would I read this equation now, this new one? It's x squared plus 4. Because there's no x. It skips it. So it'd be like saying x squared plus 0x plus 4. But we don't even need to write that because it's 0. So factored form, x squared plus 4, x plus 5. That's the entire thing. I just factored it. Solving for the solutions, we have 1 at x equals -5. That's my rational solution. How would I figure out what these solutions are?
X equals plus minus 2.
So, I set this equation equal to 0. X squared plus 4 equals 0. How do I solve that? What do I do first? -4. I square root both sides.
That's an imaginary number.
So what happens?
So,
X equals
What is it?
oh,
Is that I?
2i.
2i?
plus or minus 2i.
Good. I forgot there's
Yeah, I need to.
So these solutions are imaginary. So I have 2 imaginary roots, and then I have 1 that's rational.
What dimension does it pass over the x?
The 3rd dimension.
Yeah,
But how-
I'm going to show you
Okay.
in a minute.
so what-
It's really cool.
How do we do imaginary numbers again?
So how do I do imaginary numbers? I've got the square root of -4. Anytime, if you need a refresher on imaginary, you should be listening. So if I've got a negative under the square root, all I need to do is bring that out and it becomes an I square root 4. So a negative under the square root is an I out of the square root.
And it divides evenly, so
And then, yes, but when you square root any number, you always do the plus or minus version of that. Because it could be negative 2, it could be positive 2. Plus or minus is 2i. It's not going to get much harder than that. I'm not going to give you anything crazy.
So if it's like negative 64, it'd be
Plus or minus 8i. Okay, let's look at number 2. How many roots does it have? 5. Put this in your calculator and tell me which ones you can see. So I can only see 3 of them, and 2 of them are decimals. So, yeah, how do we even go about doing that? So I'm going to do synthetic division on the 2 first, and then see what happens. So let's go ahead and do that. So go ahead and do synthetic with just the 2 and tell me what you get. Okay, so here's what I got on the bottom. 1, 0, negative 4, 0, negative 32. How do I write that into an equation? This is x to the 4th.
x4 minus 4x squared.
Okay.
32.
Minus 32. That's interesting.
Oh, we can do, can't we do?
Can I factor this?
What did the x to the 5th go?
Where did the x to the 5th go? I did synthetic division, and when you do synthetic division, it gets 1 degree less. Yeah. So this whole thing is like saying x minus 2, x minus 4, or x to the 4th minus 4x squared minus 32. That's the whole equation. I'm just factoring it. I'm in the process of factoring it completely. So now I'm going to factor this whole thing just like a trial and error. Okay? Just like trial and error. So I'll end up having 3 parentheses. One's x minus 2. What's the trial and error? X squared plus 4, x squared minus 8. No, because it's not a difference of 2 squares. Okay, now I'm at the point where I can solve for everything. Like I can just set each one equal to 0. So I want you to set each parenthesis equal to 0 and get 5 solutions.
Oh gosh.
5 of them.
Oh yeah.
Because you have x to the 5th, so it's plus or minus on the other 2. I'm going to give you about a minute. Okay, so we got x equals 2. We have x equals plus or minus 2i, so those are what kind of solutions? Imaginary, meaning we can't see them. But we could see 3 of them on the graph, right? And 2 of those were that like 2.8, what was the decimal? 2.828 and negative 2.828. So I want everybody in your calculator right now to type in the square root of 8 and get a decimal.
I got x equals plus or minus 2 square root 2.
That's fine, 2.
2.828 is a square root.
2.828. Isn't that crazy?
But then plus or minus.
Yeah.
What?
So we call these irrational, meaning like they're just under a square root because the decimal doesn't end. So we've got the rational, the imaginary, and the irrational. So I'm sure all of you are wondering,
Yes.
I know you are, you're probably like, why can I not see the imaginary? Where are they? Where in outer space are they? They, and you don't have this on your notes because I didn't want to freak you out, but they are in a third dimension. So I need everybody to look at this for a second. I want everybody to look at this for a second. So normally when we graph on an X and a Y plane. Very two-dimensional, right? If you take higher level mathematics, like in calculus, you will actually reach and start graphing into what we call a third dimension, which is the z-plane, which is right here. The z is like, so imagine you've got x, you've got y, and z is like a diagonal. That is a third dimension. So it makes this graph three-dimensional. And so what we see, it's really cool. What we see is this parabola, but it's an x to the fourth equation. Like it goes to the fourth degree. So you have two that you can see, and then you have two that are imaginary. So what it really looks like, kind of looks like this little saddle thing. And all we see is a parabola, but really it has two more roots here and here, because it creates kind of like a saddle, and it intersects on the z-plane in the third dimension. So we don't actually see it, but if you graphed it in a third dimension, you would see that it intersects the z-plane. It's really cool.
Can you do that on like computers? Can you go graph it? That's pretty cool.
So, if you say that y was x was like z.
Yeah,
Is that
like your depth.
Is that why they have the z-axis on like maps and stuff like that?
Yeah.
Like, which Greek guy made this? Which one of them?
Greek?
I'm gonna go back. They're all math.
The only reason I know about the z-plane is because of Minecraft.
Really?
Yeah, video games actually did teach me that.
That's
I'm
awesome.
being serious. No, I would not lie to you.
It's pretty cool.
X, Y, and Z coordinates.
It's pretty cool.
Because
I'm not going to make you graph it. I just thought it would be something cool to like apply imaginary numbers to graphs, because
Definitely helps. I like
you
to
can't-
actually see.
yeah, because I don't want you to say like, okay, I got plus or minus 2i, but what does that actually mean? That would be where these are.
X to the fourth, then why isn't the parabola like the plane one just that's two-dimensional, have three curves?
Okay, wait. So,
It does in the third dimension,
Where-
so you just can't always see it.
Miss McKinley, so where is
just go with it.
like plus or minus 2i?
Here and here. Like if those were the solutions, it would be where it intersects on the z-plane.
Well, okay, I'm
But
like,
where is the Z
where the z-plane is the blue thing, it's the saddle thing, but I'm like what I'm saying is like
I thought the Z plane was a diagonal line.
No.
it's like because it go like that's what she's saying. 'Cause,
Yeah,
like,
the
it
Z-plane
goes
is
like
like,
Yeah.
through.
it's like floating in the air, and then there's like.
So you've got x and you've got y, and then you have like z. That's this So imagine z being like this diagonal that kind of cuts through it.
Because we go like this,
You
and this
pointed
goes
out on
like
the drawing.
boom.
It's okay. The blue
Right.
is the z.
Yeah, it's the thing sticking out in the blue, like here.
That's the Z.
Yeah,
Then what's the red and yellow?
x and y.
So why does the z-plane
Kylie,
curve?
Do what?
Why does the z-plane curve? Or is that because of the x to the fourth?
It's because of the x to the fourth. Yeah.
yeah, that's what I don't get.
So
Like, why
does
is
the
it?
z-plane look different for every...
Mhm. Depending on like what function it is.
Okay, so
Yeah, every function is gonna look different.
Okay, so x and y are always the same, right?
What?
But
They
does
didn't make it up.
change based
But it's
on...
not real.
We're gonna keep going. So find the zeros of each function. What would I do in this case?
X squared equals 0, X minus 4 equals 0, 2x plus 3 equals 0.
So x squared equals 0. X minus 4 equals 0. So x equals 4, and x equals negative 3 over 2.
Wait,
That
it's
can't
X.
be it.
Oh, I'm dumb.
Really?
Now, I told you that we were going to make connections, right? So if I wanted to keep going, what's something that I could maybe ask you to do on a test?
Graph it.
Graph it. Thank you. So let's graph it.
No.
I just go wild yesterday, guys.
No.
Let's graph it. What are my steps when graphing?
Draw the
Put the
down
zero.
arrow.
What now?
Put the zeros.
Yeah.
4. Negative 3 over 2.
Is it?
0.
I never know where to put the fractions because.
What is negative 3 over 2?
Negative 1 and 1 half.
Yeah, like negative 1.5.
I gotta study up on how to change those.
I have a question.
Mm-hmm.
So you said that like we can only have a number of solutions is the highest degree, so why can we have 3 here?
This is 2 solutions, x squared. It's like a multiple solutions.
So does the 0
'Cause it
not count as a
bounces.
solution?
It's like saying 0, 0, 4, negative 3 over 2. We just only have to write the 0 one time. But it's a double root, meaning it bounces at the graph. So it's like counting it twice. So we do have 4 solutions, but we only have 3 unique ones. One of them counts twice. Okay? From here, what do? I have my zeros. I look for the
No, you look
No.
at the end.
end behavior. What's the total degree of this?
4.
4. So degree is 4,
Even.
even, and is it positive or negative?
Positive.
So that means that it's going to be doing what?
Up.
Up, up.
Yeah.
And it's going to pass through. It's going to bounce.
Boom, boom.
Wait, how did
Pass
it?
it.
Wait, you said something last class, but like, where does it pass through?
What, how do I
It passes through all odd exponents and it bounces at all even ones.
So if the highest degree that we see is x squared, right?
Mm-hmm.
And we're supposed to determine whether it's positive off of its coefficient, right?
Right. So there's an imaginary 1 in front.
But it's a z. Oh, I'm silly.
Okay, let's try number 2. Now, it's not in its factored form, but we could try factoring it.
I mean, I'm not.
How do you factor? With 4 terms.
This is with the
Grouping.
Grouping, factor by grouping.
Literally hate factoring.
So you should have gotten x equals plus or minus I root 3, x equals negative 2. Remember I told you you're not going to graph imaginary, so don't worry about that. Okay, I want you to try number 3. I want you to try that from start to finish. It's like part A, B, and C. So try the whole thing.
Oh, okay.
There's no room.
What if I give you a hint when you
Wait, which one are we doing? Number 3?
Yep, the whole thing.
The entire.
So we started with an x to the 4th equation, and it gave me 2 rational zeros. And this is definitely something you might see on a test, okay? So it gives me 2 rationals, so I do synthetic twice, and I get it down to an x squared. If you cannot factor it, what do you have to do? Quadratic formula. And you just leave it like the simplified quadratic formula form. So I left it as 3 plus or minus square root of 13 over 2. So these 2 would be considered rational solutions. And these are technically 2, because it's plus or minus, 2 irrational solutions.